Hello everyone, welcome to this TwinCAT PLC HMI series video. In this video, I would like to show how can we implement the plot or curve or trend in the TwinCAT PLC HMI. This is common used functionalities in the PLC HMI system. For example, if we want to monitor the analog change, the curve or the trend can be easier for you to monitor when analog changing during one period. However, in the TwinCAT PLC HMI TF1800, there is no existing trend components in this HMI system. Instead, we can use this histogram, this component. For example, once I drag this histogram, it will show up like this. It's still pretty like a trend. However, keep in mind, in other brand HMI system, once you import one analog channel, and this trend can automatically accumulate the data and then draw a curve for you. But in this TwinCAT PLC HMI, it doesn't have a trend function. You have to prepare the data for this histogram. You have to do a data array by yourself. For example, if this trend, it has a 500 data in an array buffer, and this histogram shows 500 dots, and those 500 dots connect that 500 data in an array directly. And this histogram actually is a 500 dots combined together to be one curve, and you have to do yourself for the date shift once we have a new data. For example, you can imagine if one new data come in, so all the existing 500 data in the array need to shift one data, and then import the new data in the array. That style is like a FI, FO, first in, first out. So once one new data come in, the data at the bottom of that array need to wipe out. All the existing data need to shift one slot. So the data buffer showing at this display, you can see that that is one trend. But actually that behind, you need to program one for loop to shift this data and import the new data. So this video, I will demonstrate how can we program this. So this is the existing structure. To review how we did this structure, you can review my previous videos. In this video, I will create a new screen. For example, here. In this video, I will create a new screen. That screen especially show the trend. Okay, so let's click this visualization. Okay, let's name it trend. Okay, the default screen is totally white. We can copy the header and the Navigator frame. For example, I can go to other screens. So I can copy this header, adjust the position. Okay, go to the main, copy this navigation, this frame. So using this frame we introduced from the previous videos, we can quickly build up this template for one screen. Okay, then the key component we need to use, we need to go to the toolbox, find out the histogram. Histogram, we can find out here, the measurement controls. Find out this histogram. Okay, drag it out. Okay, here, and then we can adjust the size. We leave a little bit of room at here, so we can put one date display here. Also, we can put one more button, that button named pause. So once we click that button, this trend can be paused. And then once we release, though, the trend can be updated. Okay, so the key data we can connect to this component that is here, the data array. Keep in mind, this is one data array rather than one data only. And that data array could have 500 data inside, and each data is related to one pixel in this histogram. And those 500 dots, the pixels, combined together to a curve, showing as a curve. Okay, so we temporarily park here. Let's shift to the PLC side. We need to program that data array. This is the key area we need to show in this video. Okay, let's go to the PLC, go to POU, and here, let's add one POU here, and let's name trend program, and we can select the program, okay? And the program language, let's select structure test, ST, open. And then let's go to the global variable list, GVL, and these are existing variables we declared before. I would like to declare one constant data. Here we can type in var_global constant di train1 array max. This will be define the length of that array. Okay, and then let's go back to this train program, and other variables we can declare as a local variable. So at here we can declare this is this array train1. So that is a one array. So we start from the 1, and the length, if this array's length is 500, we can type in 500. Or like I just declared, we can use one constant value. So that constant variable, we can type in GVL dot. So that is this di train1 array max. So we declare that value equal to 500. For one project, this array's length you need to adjust to 200. Maybe next project you need to adjust to 500. So the only things you need to adjust, that is this GVL, this length. And this array, this date buffer is a date type, is a real. This is one buffer. I will create another buffer. I will explain why I created a second buffer. So this buffer named array train1 display. The reason why I create this will be used for the pause function. Okay, and then let's go back to this GVL, and also let's declare some test data. For example, I can name it analog data. So that is the float. For test purpose, I will create another tag. That tag could be added to this analog data, so we can see that value is changing. So I can name it f test. And then let's create one bool. That bool could be used to pause the display. So we can declare b train1 pause. Okay, we declare those three variables here. Let's save and compile first. So once we build this project, all the variables can be declared. And then let's go back to the trained program. Let's program that loop. Train1 array loop. Okay, so for di loop index. So our array start from 1. So we will start from 1 here, 2. The entire length, GVL max. So this is our index. So using this way, the latest data we will store at the bottom of this array. And then all the existing data will shift from bottom to the top. We are using this way. Okay, this is the for loop. So the new data we need to transfer to this array train. Okay, let's do this. At the bottom, that is this. So the last data in this array, that is this. We will transfer our actual data to the bottom of this array. So our actual data is a GVL dot the analog data. This is our actual array. So To implement the pause function, the idea is if the pause, the signal is off, we will direct transfer this array trained to this array display. If the pause signal turn on, we will disconnect the transfer from this train 1 to the train 1 display, this two array. And then we will connect to the train 1 display to the HMI histogram. So when you turn on the pause bit, the train 1 display will not be transferred, will not be updated. So once the pause turn off, the array train 1 will direct the transfer to this train 1 display. And while it's pausing, this array train 1 is still working behind. Just this train 1 display will not be updated. Okay, so we will program if not gval dot the pause button. So the train 1 pause. So we will copy the array train 1 to this array train 1 display. To copy this array, we can use this for loop. So the similar idea for. Okay, we will use this way. That means when the pause, this signal is off. So we will update this array train 1 display. This array will be the same as this array train 1. And then let's think about what the update or what the sample time to update the data showing in the histogram. The update, actually, that is the cycle time of this code. To run this code, we better use one specific task. The specific task cycle time could be 100 milliseconds or 1 second. It's the cycle time to update the value showing in the histogram. So in this demonstration, I will assume my global analog data, this data update time, that is 1 second. So every 1 second, we need to update this array train. So we will see every 1 second, this train will shift 1 slot. So to implement that 1 second task, firstly, let's go to this task. At here, let's create one new task. Add a new item, 1000 milliseconds. Task 1000 milliseconds. Double click. And here we can set 1000 milliseconds. Okay. The smaller the value at here, the higher priority this task will be, because we need to guarantee the PLC task, the control task, should be higher than others. The display, the HMI, could be lower than others, right? So we can set this priority lower than the PLC task. For example, if we go to the PLC task, its priority is 20, and this visualization task is 30. And at this task 1000 milliseconds, we can set 31 lower than this existing two. Okay. And then let's build this solution. And then we need to create one task here. So right click, click add, and add this reference task. And then let's select this task 1000 milliseconds and name it. We can name as the same name, task 1000 milliseconds. At here, right click, click add existing item. We can select this train program. Once we select as this train program will be called by this task, and this task cycle time is 1000 milliseconds. And then let's go back to this trained program. And to demonstrate this analog data changing, so I will program one test program. This analog test signal will be added 20 per second. So once this value reach or equal to 1000, it will reset to 0 and start from 0 again. So we will use this signal as a test signal showing in the train. Okay, this is my test code. And then let's go to the HMI side and connect the histogram to this array train 1 display, this array. Okay, let's go to the PLC HMI. Go to the trained and come here. And let's go to the data array. Here, if we browse, we will see, go to the trained program, click this array train 1 display. Firstly, let's adjust the width of this train. And because of this screen, the width is 800 pixels. So the maximum width of this train should be smaller than 800. So the current width is 770. Okay. And then let's adjust this scale. And because our data, I will assume that is one temperature data. Temperature can go from 0 to 1000. So we can set this scale start from 0 and end at 1000. Okay, and then the main scale we can adjust. For example, the main scale we can set 200. So once we adjust this 200, we can see this is the main scale. So every 200, it will show one value at here. And this subscale is at here. Actually, this subscale we can set 50. So the 50 is this single subscale at here. So that is a 50. Okay, this is the main scale. And this is the minimum. This is the end, 1000 at here. Okay, and this is the color setting here. We temporarily use this default. And because we are going to show the trend style, so the display type here, we can change to the curve, this style, the curve. And the line width, we can change to wider. For example, let me change to 3. So, and keep in mind, this is a scale format. So we can double click here, adjust it to wider, and we can see this is %. So that means we show 1 decimal float here. So we will see there's 1 decimal. That is a float format. Okay, till here, we basically finished that. Other than this, let me drag one test field to show the actual data. Drag another button to connect that pulse variable. Okay, firstly, let's go to the toolbox and go to the test field. Drag to here. So to show the value, we need to go to the test variable. And this test variable, let's double click, select the analog. The analog comes from the GVL. And that is the analog data here. Click. And the format, we need to change the format. Go to text. Let me type in %. So let's leave 4 digit at the left of the decimal point and 1 digit at the right side of the decimal point. That is a float. So that is the format. Okay, right here. And then let's drag one button. So go to toolbox, button. And this button will be the pulse. So let's firstly name this button is a trend pulse. Okay, add here this test, so we can change the name. And the actual function, we can go to the toggle. So connect to the variable, to that bool trend1 pulse. And to show the trend pulse status, we can also connect to this tag to the color variable, toggle color. So the color will be controlled by this variable. And the actual color will change between this blue and to this alarm field color here. Okay? And the actual color will be shift between those two colors. And then after this, to allow us, we can jump from this main screen to this trend screen. So let's add one navigator button at this navigator area. So we go to the navigator, this subscreen, and let's implement another button at here to jump to that trend. So we can go to the toolbox, drag this button, change this name trend first, and then go to the input configuration. On mouse down, so double click this config and select this change shown visualization. And at this assign, let's select the trend screen. Okay, click OK. Once we add this button here, and if we go back to other screens, we will see this trend button will be updated to every screen because we are using this frame, and this frame call this navigate this screen. Okay. Now let's save and build the project, and let's download. hit this downstairs active configuration. Download the hardware portion. Okay, restart. So once you see this, that means our controller is running this program. This program is downloaded to my laptop. I'm using my laptop. Okay, let's hit this login. We can see the local showing here. That means we are using our laptop for this test. Okay, now if I hit this trend, we will jump to the trend. Because I'm using my test logic, every second this value will be added 20. So this value will be shown in this trend. Okay, and if now I click this pause, so we will see this value will be still changing here, but this trend will not be changed. Let's wait for a while. And let's review. If we go back to our logic, this trend program, we will see. So because this trend pause, this signal is on. Because this trend pause is on now, so this area will not work. So this area trend display will not be updated from this array trend 1. Okay, so if we go back to this trend, if now I enable this trend pause, boom, it will shift here. That because behind our original array is still working there. So once we enable this trend pause, so all the data, once we release this button, the data in this trend 1 display will be updated by that trend 1 array. While it's pausing, the data behind will not be lost. Okay, let's go to the program side. Let's quickly review. And keep in mind, those programs are updated by this task of 1000 milliseconds. And its cycle time is 1000 milliseconds. So actually, to show this trend, to use one array showing in this histogram, the core function is this area. So using this for loop, we loop and shift the data every time we run this program. That is 1 second cycle time. Currently, we are using this task of 1000 milliseconds. You can imagine if we trying to use the event to update this trend. For example, once you task done at the bottom of your sequence or your task complete, you can call this for loop 1 time. So that means every time when your task done, you shift this data and the data shown in your trend will be updated 1 time. So the trend can be used to record one important data per production cycle. So that is 2 different styles. The current style, we are using this cyclic task that can be aligned with the time. That means the x-axis is a time frame. But if you are using the trigger event, so the x-axis in the trend is an event. This is a 2 different styles. Okay. So that is the TwinCAT PLC HMI trend function. Even if we need to program a little bit additional code to implement this trend, actually the core area is just couple lines here. If you have a multiple trend, so you can program the similar code, change this array to array trend 1, 2, 3, 4. So you can use this code as a template. Okay. Another thing I would like to explain. The current trend is shown in the PLC HMI. And another trend style, basically we can call that measurement trend. To implement the measurement trend style, we can go to the project, right click, click this add this new project. And then you can select this, the TwinCAT measurement here. This is one individual measurement trend function from the TwinCAT. I used one video showing how to use this TwinCAT measurement before in the PID series video. That trend can show the set point and the PID feedback loop and the PID control signals. This is one professional style to show the measurement. And this style is a simple function. For example, if you have a couple analog signals need to show to monitor the trend change, so you can use this style shown in your HMI. Alright, that is for today. Thank you for watching. Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe and hit the bell. Thank you for watching.